Welcome back. I'm so glad you could join me again. Yay. It's always a good sign when they come back after the first lesson. Anyways, we're going to move on to subsets today. We already introduced previously what sets are and a few definitions about them. So now we're going to start breaking up sets into subsets. If you divide sets up into subsets, then if you have a subset, then any elements that are in the subset are going to be found in the set that you pulled it from. All of ILM's elements are going to be found in N. So if set ILM is the subset of set N, notice the symbol, how it's symbolized there with that sideways U and the line under it, then all of ILM's elements are found in N. Okay, for example, let's say, I have to pick my pen here. Ooh, I don't want red, I want black. I don't want to act like I'm screaming at you with the red. Okay, so let's say that set N contains, I'm just making up the set here, so let's say that set N contains something like little a, little b, little c, little d, little e. And let's say we pull from that, let's say we have a set ILM that contains A, C, and E. So in this one, all of ILM's elements are found in N. So ILM is a subset of N. But let's say we have another set, let's call it R. Just making up letters for the names. And notice I'm writing these sets in roster form, just putting some elements there. And let's say I have a set R with the elements B, D, E, and G. Well, set R is not a subset of set N. And that's actually the official symbol right there. So you do the subset symbol and then put a slash through it. That means not a subset of. Because this one element, G, now I'm going to change to a different color. This one element, G, right here, it is not found up there in N. So if you're trying to do a subset and it has any elements that are not found in that original set, then it's not a subset. So just be aware of that. All right, so let's go dive a little bit further into subsets. A proper subset is a subset that is not also equal to N. So if T is a proper subset of N, then the notation is T, and that little sideways U shape, and then N. Notice it looks a lot like the subset symbol, except it doesn't have that little line thing underneath. So proper subset is that sideways U, but no line under it, because it can't be equal to. So it can't have that little like almost equals to line under there. Okay, so let's say we have set N that contains, I don't know why my pen does that sometimes, star, at, asterisk, and pound. We separate the elements with commas. Alright, so let's say we have set T that contains star, asterisk. Okay, so all of T's elements are found in N, and T does not have all of the elements that N has. So we can say that T is a proper subset of N. We can also say that T is a subset of N. Both apply here. But let's say we have a set called V, and it contains asterisk, pound, at symbol, and star. Well, V is certainly a subset of N. All of V's elements are found in N. But V is not a proper subset of N. You can do the little proper subset symbol and put the slash through it to say that's not a proper subset, because all of V's elements are found in N. In fact, V equals N. And that's what keeps it from being a proper subset. So that's the difference. Proper subset's still a subset, but it can't be equal. It can't be basically the same as the original set. Now, if you want to see how many possible subsets can be made, or how many possible proper subsets can be made, there's actually a little formula you can use. The number of total possible subsets, you can use 2 to the n power, where n is how many elements you have in your set. And then proper subsets is just one less than that, because the proper subsets cannot include the original set. Alright, so let's do a couple of examples of that so you can see. Alright, let's say we have set A that contains alpha, beta, and delta. Okay? The cardinal number of set A, in other words, the number of elements in set A, is 3. So the number of subsets possible is 2 to the 3, or 2 times 2 times 2, which is 8. Okay, so let's list them. Well, I could make a subset with just alpha in it. That is a subset because the element alpha is found in set A. I could make a subset with just beta in it. I could make a subset with delta in it. I could go 2 at a time. Like that. I think I got them all. Or I could do all 3. In each of these sets, the elements are all found in set A. Now that only accounts for 7 of them, though. Any guesses as to what the 8th one is? Normally in a face-to-face class, it takes a little while. Sometimes somebody will figure it out. Sometimes they don't. The empty set is actually a subset, too. And you're like, well, how can that be? It has no elements in it. Well, the definition only says that a subset's elements must be found in the original set. Well, the empty set doesn't even have elements, so it still fits the definition, technically. So whenever you're trying to figure out all the subsets, the empty set's always going to be one of them. Then if you want to talk about number of proper subsets, let me switch colors here so that we can be talking about a different concept here. How about we go with green? Hopefully that'll show up okay. Number of proper subsets. That's always 2 to the n minus 1. That's, in this case, 8 minus 1, or 7. And it's that because it's all the subsets except for the one that's equal. So in this case, these 7 here are the proper subsets. So a proper subset cannot include the one that has alpha, beta, and delta in it. So 8 subsets, 7 of them are proper. Okay, so there you go. You should have lots of fun in your practice with subsets. And tune in again next time. We're going to continue talking about sets. And pretty soon it's going to be very exciting because we're going to get into Venn diagrams and do some drawing. Ooh, I like that part. Thank you for joining us.